Great, hello, and thank you very much for inviting me to lovely Leeds to talk to you today. It's and it actually looks like it's going to be an excellent conference today. I'm really looking forward to an awful lot of the talks that are coming later. It's the mark of a good conference. When I'm looking at the schedule, I'm thinking, oh no, I want to watch that, and I want to watch that, and I'm definitely feeling that today. So I think that's a really good thing. As Andy said, I've been in tech for a long time. Not quite, but nearly 25 years. I've worked on a lot of different projects, a lot of different engineering projects. And these days, I am interested and involved with cloud native. And normally, I get on stage and I say, oh, cloud native, it's great, and here are all the good things you can do with it. But today, I'm going to do something a little bit different, and I'm going to talk about the dangers I see with it. And I do see some very, very clear dangers. And I think that those dangers explain some of the stuff that we're seeing in the press, seeing going on in our industry at the moment. And it's something that I think that we need to be paying attention to. And I think that if we might not think we can take action, we might not think we can do anything about it, but actually we can. And that's what I'm going to talk to you about, is the future of the tech sector. What is our destiny? Where what's going to happen to the soul of technology? Are we going to become villains or are we going to become heroes? But first, I'm going to give you a little bit of an overview of cloud native, which is kind of a little bit what Ian's just been talking about. So there we go. Right, excellent. Everything is working. So cloud native is a really terrible name. I use it quite often myself because everybody seems to use it. It means optimizing your infrastructure and your architecture for running on cloud infrastructure and also using cloud services. Now, I don't know why it's called cloud native rather than something like cloud optimized, which would be a much better description of what we're talking about. Presumably somebody couldn't get the URL or something. And so we are left with cloud native, and we'll have to live with it. So what is the definition of cloud native? According to the CNCF, the Cloud Native Computing Foundation, who you should presumably know, it's microservice-orientated, dynamically managed and containerized applications. Now, I think that's not a terribly clear description. I'm going to talk through a little bit about what it is now because it's quite key. Understanding where it comes from and understanding the motivations for adopting it are key to seeing where some of the problems are coming, some of the social problems are coming out of using this technology, which is incredibly powerful technology. So why are we using it? Before I start describing it in detail, what's the underlying motivation? Well, as Ian mentioned, it's about going faster and scaling bigger and scaling faster as well. So we're really using these techniques and using them on top of flexible cloud infrastructure to get products to market really, really quickly and to scale them to enormous sizes. And that, unsurprisingly, is quite attractive to businesses at the moment. So that's the underlying motivation. And I think that there are 6 parts to this. It's not a simple process to go cloud native. There are kind of 6 steps. The first is it's throwing away your inflexible old infrastructure, your machines sitting around in your own data centers, and moving to flexible cloud infrastructure. Now, in the early days, we thought that the cloud was really going to be about saving us money. I don't know how on earth we thought that. If you move to the cloud, you're not really rolling around in all the money that you save versus running on premises. The actual, what has turned out to be the advantage to the cloud is the flexibility. It's the ability to get infrastructure by servers or by services on demand, see if we like them, and then if we like them, keep them. If we don't like them, give them back, and don't spend any more money on them. It's that flexibility. And what that flexibility has ushered in is a new world of experimentation, because it's de-risked. One of the riskiest parts of planning a new architecture, making a technology change, was the fact that you were kind of locked into the physical service and the services that you'd bought. Once you'd invested in them, you kind of stuck with them. So you couldn't really afford to make a mistake. But because you can now buy things, and not cheaply, but you can buy them online, you can get out your credit card, you can get a machine, you can try it out, you can try out a service, give it back if it doesn't work. That's de-risked that. That has allowed us to be experimental. So when Ian was talking about being more experimental, that only really works. The reason why everybody wants to do it now, as opposed to they didn't do it before, is because it's not as risky as it used to be if you're on the cloud. So the next thing, and Ian also mentioned this, is automate. So all the APIs that the cloud exposes, and the fact that we now understand the enormous value of APIs, well, I think we always did, but it wasn't quite as well understood, means that you can automate an awful lot of your processes. You can remove those pesky humans from your deployment, from your integration, and that speeds things up. It also makes things more accurate, it makes things more scalable, reduces those bottlenecks when humans don't always get on well with one another, or communicate as effectively as we could do. So we're removing all of those pesky humans. We've got the CI/CD, and there are some great tools out there now, things like Jenkins, Drone, Circle CI. There are just tons of good products out there to use. And then we can obviously automate the creation of our infrastructure and the setup, things like CloudFormation, things like Terraform, loads of good products there. And of course, we've been automating testing for a long time, but that is still utterly key. Lots of great products out there for doing that. So automation, it's an absolutely key part of going cloud native. And the order that I'm talking to you about this is generally the order that I see people are adopting this, going down this route. They're trying out the cloud first, they're automating very quickly, and automation is utterly key. There will be other speakers who talk to you about how important that is later today. Now, cultural change. Part of moving to this new cloud native world is that we don't feel terribly locked into any decisions that we've made, and we can't feel culturally all that committed to things that we've done, to tools that we're using, because there are always better tools. There will always be better tools coming along. We can't feel that we're we're failing by giving up on something and moving into something else. We cannot emotionally become too attached to anything. Now, as you say, no downside to this kind of attitude. We need to constantly feel that we can change and move forward, and that is what success is in cloud native. There is a well-known speaker called Adrian Cockcroft that some of you may have seen. He now works at AWS, and he constantly talks about cattle not pets. Cattle not pets as an approach to your servers, but really we're extending that to everything. That nothing is sacred. Everything can be improved, can be changed, can be experimented with. Now, the next thing on the list is microservices. So this is a new architectural technique where we say our old pet of our monolith, it's too high maintenance for us now. It's hard to enhance. It's hard to redeploy. It's hard to secure. We're going to do something easier, which is we're going to break up our giant monolith into lots of small pieces, microservices, smaller applications that small teams, like those two pizza teams, can work on, that are separated, that are radically decoupled from one another using APIs. That means that that has two effects on your setup. Operationally, it means that you can effectively scale horizontally. So you can have lots, if you need to scale up your application, you can just run more copies on more machines in more distributed locations, because they're not only decoupled from each other, so two different services are decoupled, but usually in most cases, usually services are decoupled from other instances of themselves, which means that you can more effectively scale by running more copies. It's also more resilient because you can run multiple copies, and if one of them falls over, the other one can keep things going. It's also potentially more automatable, which we'll get to later. So that's all useful. And organizationally, because your teams can work on smaller applications that they know about, and they don't necessarily have to interact so closely with other teams, you can parallelize and move more quickly, move products into production more quickly. Now, I am going to get to the downside of all of these things. Don't worry about it. The next step, and obviously I'm rushing through this because we've only got, this is only the first half of my talk, is containerization. So I'm sure most of you have heard of Docker containers, the idea of wrapping applications in a shell, effectively, a virtual shell that's much more lightweight than a virtual machine. So application isolation with, again, those great APIs that mean you can move your applications nice and easily from one machine to another, whether that's dev to test to production, or move it around in production. So it works extremely well with the automation that I was talking about earlier, the CI/CD, because that's dev, test to production. But it also works well with orchestration, which is usually the final step in going cloud native. So an orchestrator is a tool like Kubernetes, which now appears to be winning. There's also ECS, there's things like Nomad, but Kubernetes now does appear to be hands down winning, which in some ways makes life much easier. So these tools allow you to take your containerized application and move it around and automate the moving of that around. So automate getting things to production, lots of exciting new ways of deploying products that would be too labor intensive to do manually, things like blue-green and canary deployments. And I mean, I guess we did used to do it, but it's a bit more sophisticated now. We've automated it. And also, and the bit I like, the reasons why these things were invented in the first place is automating operations. So being able to spot when applications fall over and restart them, or spot when you need to scale up and start more instances. So tons of useful automation coming out of tools like Kubernetes. So what is cloud native? It's a 6-step process in which you have to completely redesign your organization from the ground up to be highly experimental and throw away all your old thinking and absorb all the new thinking, not just in tech, all the way up. We have to move to the cloud. We have to move all of our applications to the cloud, move to that flexible infrastructure. And we have to automate everything, automate all our testing, automating all our development. We have to move from a monolithic, quite an easy monolithic architecture, to a massively complicated microservices distributed systems architecture, which is really, really hard to do, with tons of operational problems and tons of development problems. And then we have to containerize, which is actually probably the easiest bit. And then finally we have to run an orchestrator in production, which is a really difficult bit of kit to operate, really quite complicated. And then on day 7, we should just have a bit of a rest, I would say. Because fundamentally, isn't this crazy talk? Because all of those projects are huge. They're all really, really difficult projects to do. And I'm saying to go fully cloud native, we have to do all 6 of them, when any one of them would be a massively tough project to even be attempting. And yes, it is really hard. This transformation is a multi-year project, and it requires huge amounts of buy-in. It's very, very difficult to do. The tooling is getting better. It's getting much easier to do it now than it used to be. There are more managed services that do some of this stuff for you, but nonetheless, this is a very, very difficult project to do. So why on earth? There will be a few people here that I know who've done extremely well at it. A few of the later speakers today, and they've taken, best case from a kind of blank slate, a year or two, best case, in a more normal state, multiple years. So why on earth would we want to do it? It's the payoff. The payoff for doing this is quite extraordinary. It is a 2 or even 3, often 3 order of magnitude change in how quickly you can get products or features into production. And that's a kind of industrial revolution style change of speed. And that is why people are willing to put all of that time and effort into doing it, because it is a lot of time and effort. It's a giant pain in the neck. Now, when I talk about 2 to 3 orders of magnitude faster, I don't mean that, if you have one product and you know it's really well defined, you know exactly what you're doing, you're writing a IP router to a spec, you'll go 1,000 times faster if you use these techniques. You won't. In fact, quite probably you'll go much slower if you use these techniques. It's not about bandwidth. This is about latency. It's about your ability to pull off little bits of so you've got an idea of a product that you might want to build. It's the ability to pull off small chunks and put those into production much, much faster. Get feedback on them, get your feedback loops going, and find out whether you're actually going to want to do things that way or you're going to want to do things differently. And maybe you won't then have to do this whole thing. Maybe you'll only do a small bit, or maybe it'll look completely different by the time it actually goes live. But it's about feedback loops. It's about latency, or reduced latency, not increased bandwidth. But nonetheless, and that will not suit every business. But if it is a business where you will get advantage from it, then it is absolutely well worth considering. If you've got user-facing products, for example, absolutely. If you're not doing it now, you have to worry about whether you might have a competitor who will do it in the future. So it is worth thinking about the investment. But nonetheless, 2 to 3 orders of magnitude improvements, that is a no-brainer, isn't it? That is fantastic. We're like superheroes. There's hardly anything that could be better than that. It's just it's all good. It's all good. There's no downside. Well, now I'm going to segue into a completely different thing that has nothing whatsoever to do with cloud native, which is ethics in technology. Now, it seems like recently there have been an awful lot of reports in the press about ethical scandals going on in tech, in social media, Facebook, Uber, Volkswagen. It's an unfortunate coincidence, isn't it, that they all seem to be happening at once and at huge scale. You think, well, it's a bit of a shame. Is there anything more to it than merely coincidence? Is there any kind of trend here that we might have to think about addressing? Now, for the first time, Stack Overflow. So you might have seen the Stack Overflow Developers Survey for 2018 that came out last month. And for the first time, Stack Overflow asked 3 questions that were about ethics. And the first question they asked was, do you, as a developer, think that you should consider the ethical use of your code? You should consider what your code is going to be used for, whether it's going to be used ethically or unethically. And 80% of developers said, yes, I think that we should consider what our code is used for. So, actually, it can't be us. We're like heroes. That's great. We're totally goodies in this, and nothing could go wrong. But then they asked another question. And the second question that Stack Overflow asked was, if you were asked to write unethical code, would you? And 40% of responders said yes, or it depends, where I'm reading it depends as yes, but I'd feel bad about it. But I'm gonna say, look, yes, you probably would. And the third question that Stack Overflow asked was, who do you think is ethically responsible for the code that you design, write, test, and deploy? And 80% of developers said, not me. Not me. Somebody else. Only 20% of developers felt that they're ethically responsible for the code that they wrote, designed, tested, and deployed. So who is responsible? Product managers, product owners, shareholders, boards? But the trouble is, they're all quite a long way away, aren't they, from the actual decision to what we're going to build. But anyway, but that is a little bit worrying, because that suggests that maybe we're not heroes. But I wouldn't go so far as to say we were villains, because and probably the fact that 80% would quite like to think about the ethical implications of our code doesn't necessarily mean we're heroes either. We're kind of more like normal human beings, according to your fellow Yorkshireman, Philip Larkin, who wrote a very interesting poem on the study of reading habits about whether people really are heroes or villains. And I won't read out the whole poem to you because I've only got 20 minutes and I'm already probably almost certainly overrunning. But basically, in this poem, which you should read because like most Philip Larkin stuff is very good, he says, well, you know, as a child, I was really keen on reading books. I was really keen on reading. And as a child, I used to read books and think, yeah, I'm going to be a hero. I'm a hero. And then as he got older, he thought, yeah, maybe I'll be a villain. And then when he got to middle age, like me, he realized that actually he was neither a hero or a villain. He was more like the guy who leaves the girl before the hero arrives, or, you know, the cowardly shopkeeper. And so he went off books. I have not gone off books, but I can see where he's coming from there. If Philip Larkin isn't a hero or villain, then really, can we be expected to be heroes or villains? And if we're not heroes or villains, then any solution that we could come to about ethics for devs can't rely on us being heroes or villains, because that's an unrealistic thing to do. Now, I'm not entirely inclined to take only Philip Larkin's word for the fact that humans are neither heroes nor villains. There is quite a lot of scientific evidence to back that up. So there's a British psychology company, the Mind Gym, did quite a lot of research into this, and they found that there are 5 or 6 circumstances in which pretty much anyone will behave unethically. So, and they're kind of ones that you would guess. So we will behave unethically if the people around us are behaving unethically. It's the standard. It's what everybody's expecting. If we feel like we're in an unfair environment towards ourselves or others, then we're not that bothered about behaving fairly ourselves. If we're in a rush, if we don't have time to think about it, if we're just doing things very quickly, that's a bit of an ethical anti-pattern that can easily make us behave unethically. If we're only seeing a small piece of the picture, or we're just moving, it's a slippery slope. We do one small, slightly dodgy thing at a time, it can all add up without us really noticing it. And finally, if we feel like there's a huge loss to us if we don't behave ethically, if we do behave ethically. So if we're going to lose our jobs, then we will certainly behave unethically if asked. The trouble is, this is kind of like being at work. So how are we going to handle being ethical in this new world where we have considerable power, when it's very difficult for us to be ethical, for anybody to be ethical in any normal working environment? How are we going to do it? And cloud native is a bit of an ethical. I realized after looking at this is all stuff that I've been interested in for a while, and I've realized looking at the cloud native approach that it's a bit of an ethical triple whammy. It's all about moving very quickly. So the idea is you have an idea and it's in production kind of like maybe 15 minutes later, you know, is what we're aiming for. So we have very little time to think about what we're doing and whether it's a good thing to do. You know, love it or hate it, Waterfall, we had plenty of time to think about stuff. That was, you know, but pros and cons. Also, in the cloud native environments, this whole radical decoupling, where everything is much smaller, you see a much smaller part of the picture. So it's much easier for us to move into this mode of, I'm not necessarily, this bit is a bit dodgy, but you know, it's only a bit. And not see necessarily the big picture, how that's all adding up. And then finally, probably the most important part of the triple whammy is the scale. Is that we can really scale to enormous size with what we're doing with cloud native, which means the impact, and impact can be good and bad, the impact of a bad decision can be very significant. So what can we do? And I think this is the reason why we are suddenly starting to see ethical problems coming up in the press, because it's companies like Facebook that have enormous scale. If they make a decision and it's a wrong decision, if it affected 100 people, yeah, we'd just learn from it and move on. If it affects 1 billion people, well, that's a whole different problem. And those Stack Overflow developers were not utterly wrong when they said that they didn't really see themselves as responsible, because it's quite hard to change things. It's quite hard to get a company to throw away a dodgy feature that's generating a lot of money. And we don't have the soft skills for that. We don't all make rousing speeches, Shakespearean speeches, moving all our colleagues into a completely different ethical direction. That doesn't happen. So they're not being unrealistic when they say, how can I be held responsible for the overall ethics of a company when I'm just one person with let's face it, we're engineers. We don't have the best soft skills in the world. We are unlikely to go into politics and change the whole direction of the human race. So do we just lie back and think, well, we can't do anything about it. We're just individuals. We can't do anything about it. So we should just take the money and write the code, which appears to be the direction that I'm a hint of a direction that I'm getting from that Stack Overflow survey. Well, I think we're kind of, right now in the industry, we're kind of at the end of the Empire Strikes Back. It's a difficult point. It seems like we can't possibly battle back against these ethical dilemmas that are facing us. We can't change things. We can't sort it out for ourselves. But we're wrong there. One thing that I noticed from working with, managing software engineers for well over 20 years is that we're terrible at underestimating our own power. We do actually have considerable power to change what goes on in our companies and in the world in general. Fundamentally, no code gets deployed without going through us. And all of this stuff is code. Everything that you see in the press that people are complaining about happening, it's all code. It all has to go through us. So actually, we are in a position where we could do something about it. But we also have the power to do something about it. We've got consumer power, because actually we have budgets, and we have significant budgets. And we also have professional power. And we should not underestimate those. So, for example, here's a great example, I think, of consumer power for all of you folk in the audience today, which is that you're seeing me on stage at all. Because 10 years ago, there weren't really any women talking on stage at tech conferences. But now, actually, there are quite a lot of women. And we usually broadly reflect the percentage of women in the tech industry, which is it's not great, 15 to 20%, but at least we broadly reflect. And that wasn't the case a decade ago. Now, that change has not taken place because conference organizers are all hippie do-gooders. And it's not taken place because it's easy, because actually it's really hard to get people who are not part of the usual suspects on stage and talking at conferences. It's happened because conference organizers get a lot of complaints from conference attendees if you don't have any women, if you've got an entirely male speaker list these days. Attendees, developers, have exerted their consumer power, their soft power, to make a significant change to the industry just by complaining. We can all complain. That's easy. I love complaining. It's not even a bad thing. So that's an element of soft power. And we all have budgets. We can extend that consumer soft power to other purchasing decisions we make. We can ask our vendors what their policies are, how they use algorithms, how they make sure that their data is accurate, whether they reach out, whether they do have a diverse workforce. There are so many questions we can ask. Actually, the one I would tend to ask is, how energy efficient are their data centers? Which is something that I care about a great deal. There are lots of things that we can do that don't even have to be terribly difficult. But the other thing we can do, we do have another power as well. And I'm working on this at the moment. We're at the beginning, we're at the end of Empire Strikes Back, but we still have the whole of Return of the Jedi yet to come, where we turn this around. So we have our consumer power that we can exert, but we also, what we're very good at is creating, following, and automating rules. So at the moment, we don't have any processes in place for making sure that what we do is ethical. Because if we right at the beginning of this, we've only just seen that the problem has arrived. And we are going to, I'm working with a couple of groups to try to crowdsource, develop some ethical processes, points where we, of reflection within the agile process, where we can think, are we okay with this? Points of backward reflection as well. So places like in your retrospective, we did that. Are we happy with it? It's gone live because there will always be mistakes. Things will go live. Are we happy with it? Do we want to go back and change it? Doesn't necessarily mean you have to drop a feature. Maybe you just need to change a feature, tweak a feature, because that's the ideal. You don't really want to be going backwards. You want to be improving. Are there changes, improvements that we can make that will address things that are making me, because actually humans are very good at identifying ethical issues. If you've got a bad feeling about a product that you've just put live, or a feature that you just put live, go back and examine that feeling and address it and say, was there something we can do about that? Don't ignore it. There are loads of things we can do, and we are right at the beginning. We are so good at following rules. We will do it. We have to do it, and therefore we will do it. In the long run, we need to be the last bastion of defense against unethical code going live, and we can do it. So if anybody wants to talk to me about that, or anything, or cloud native, or anything at all, I will be around all day, and I'm always very happy to talk. So just come and grab me, and have a lovely rest of the conference, and thank you very much.